So last time we discussed the structure of a viable prefix. Today we're going to discuss how to recognize a viable prefix using an automaton. Recall that last time we said that a viable prefix, the language of viable prefixes is a regular language, and so it should be possible to develop a finite automaton to recognize whether something could be a viable prefix or not. And so to do that, we're going to today construct an NFA that is going to say yes if alpha is a viable prefix, and the way it's going to work, it's going to read alpha left to right or bottom to top in the stack. And if it says yes, then it is a viable prefix, and if it says no, then it is not a viable prefix. Recall that if it is a viable prefix, then we have hope in our shift reduce parser to be able to reduce to the start symbol eventually. But if it's not a viable prefix, then we have no hope. And so this can be a good test on whether we should shift or reduce in any state of our shift reduce parser. So all right, so we're going to discuss an algorithm given a context-free grammar, an algorithm that constructs an NFA for that context-free grammar to identify the set of viable prefixes. So here's the algorithm for the NFA construction. The first thing I'm going to do is I'm going to add a dummy production. S prime produces S to G. So if the start symbol if the grammar G is S, then I'm going to introduce another symbol called S prime and make S prime the new start symbol of G. The only intention of doing this is so that we are sure that S prime doesn't occur anywhere inside the RHS of any of the productions of G, whereas S may be allowed to appear in the RHS of the productions of G. And that's just a matter of convenience so that we can uniquely identify the start state. All right. Then the NFA states are the items of G, right? So we already discussed what are the items of G. Items of G are any production of G with a dot placed somewhere in the RHS of that production. So the NFA states are the items of G. And for example, one of the states could be E produces alpha dot X beta, all right, where E is a non-terminal. Alpha is some string of terminals and non-terminals. Dot is the pointer which represents the item. Capital X is a non-terminal, and beta is again some strings of terminals and non-terminals. So for such an item, we add a transition from the state of that item, which is just that item state with an oval over it to represent that it's a state, and then we add a transition of this type. So if you see X as the next input in your alpha, which is the string that you want to check for whether it's a viable prefix or not. So if you see the symbol X, then you transition to this state, which is representing the item E producing alpha X beta, which is the same production except the dot has been moved after X, which means I have already seen X. Okay. All right, so that's one type of transitions that you add. Further, you add another type of transitions, which is if you are in this state E produces alpha dot X beta, and there's a production which produces gamma from X. So X produces gamma. Then you add an epsilon transition from this item, which is E produces alpha dot X beta, to this item X produces dot gamma. Okay, so there are two types of productions. I should point out that in the first type of production, which is step 2, X could be either a terminal or a non-terminal. All right, so this can be either a terminal or a non-terminal. Whereas in this step 3, X should be a non-terminal. Only then it makes sense, right? Okay, so we're going to add an epsilon production. So what this means is that if I'm in the state where I've already seen alpha and my next non-terminal is capital X, then I could non-deterministically go to this state where I expect to see gamma as my next prefix, right? So this is basically saying that I have decided to terminate the prefix here of this production and then continue from the prefix of the next production. And so intuitively you can see that this is going to start recognizing language that is formed by concatenating zero or more prefixes of any of the productions of the grammar. Okay, such that also recall that we had this rule that the LHS of any n+1th production is just follows the dot in the RHS of the nth production, and that's kind of what's happening here. So we are adding epsilon only if x followed the dot, and the transition is happening to a state where it represents a production of capital X, and the item is the one that's basically has not consumed any symbol yet. So dot is on the leftmost side of the RHS. Okay, with that construction, we need to basically figure out what are all the accepting states. So when are we going to say that indeed this is a viable prefix or not? And so in this case, every state is actually an accepting state, because any state here is going to represent some prefix of some concatenation of prefixes of productions, and so every state is an accepting state. So which means that if I end up in any state in this after having finished the input, then it is a viable prefix. On the other hand, if I ever get stuck while executing the automaton on some input, which means that there is no transition, then basically I have a situation of it being not a viable prefix. Right. The start state is this represented by this particular item. S prime produces S with the dot to the leftmost. Right. So you start with this. Start in this state, and then we see whether the automaton accepts the viable prefix, the candidate viable prefix or not, by checking whether it is formed by a concatenation of zero or more prefixes of the productions. Okay, so let's look at an example to make this discussion more concrete. I'm using the same example grammar that we have been using so far, which is a grammar of expressions. E produces T plus E or T produces int star T or int or parenthesized E. Now, as I discussed, we are adding one extra production here, which is S produces E, and this is just an extra production, and now my new start symbol is S, and hence my initial state is just S produces dot capital E. Right, so this is my initial state, and now I'm going to develop the NFA based on this grammar. I'm not going to show you the entire NFA because it's too big to fit in the slide, but I'm going to show you some part of the NFA and how I'm constructing it. And it should become clear how the rest of the NFA would be constructed from this. So I start with S produces dot E, and now I can add two types of transitions. One is I can add a transition to which consumes E, and I can add epsilon transitions to items that involve productions of E. Right, so that's what I'm going to do next. So here are two types of productions. One is consuming E and producing S, and ending up in this transition in this state. S produces E with dot on the right of E, and the other transitions are epsilon transitions to the productions of E. So the two productions of E are E produces T plus E and E produces T, and here the dot is on the leftmost side. Okay, now let's look at the first production here, right, which is E produces T plus E, and with the dot on the leftmost side. Let's look at this item, and now once again either I could consume T to transition to another item, or I could transition using epsilon moves to the productions of T. So here it is. I could either consume T and transition to this particular item where the dot has been moved, or I could perform epsilon transitions to, for example, other productions of T. So T produces E or parentheses E, or T produces int, or T produces int star T. Okay, I can keep doing this. So for example, I could look at any one of these states here. So for example, I could look at E produces T dot plus E, and once again I could consume plus and move my pointer one step to the right, or I could make transitions. So notice that there are no epsilon transitions from this particular item because the next symbol is in terminal, not non-terminal. But if I look at this particular this particular production, E produces T, and this particular item where dot is to the leftmost, then it has epsilon transitions to all the other productions of t. So this has an epsilon to t produces dot int star t, t dot int, and so on. Also notice, also similarly, I have a production from t produces dot int to t produces int dot after consuming an integer token. Okay. Similarly, here I could consume. I'm kind of using a shorthand. I'm consuming two tokens in one go because they both happen to be non-terminals. So they both happen to be terminals. Sorry. And so it's going to consume int and then consume star, and eventually it's going to land up in a state which is t produces int star dot t. And I can do more transitions here. I can add more transitions. So for example, I can transition from t plus dot e to t plus e dot after consuming an e, or I could transition from int star dot t to int star t dot after consuming a t, and so on. Here, even here, I could, for example, so consume a left parentheses and go to more items. I'm using a star to say that I'm not drawing this part of the NFA for you. Okay. And now here, notice that because the dot is just before a capital T, I will add transitions, epsilon transitions from this item to the productions representing the items representing productions of T. So T produces int star T, and T produces int, and T produces parenthesized E. Okay. Notice that in this automaton, I now have a cycle. So I could have int star, int star, int star, int star, int star, lots of int stars, and they would still be a viable prefix. Okay. All right. Okay. Similarly, I would, anywhere where there is a dot just before a capital E, I can add epsilon transitions from that item to all the productions of E. So I'm going. So here's an epsilon transition. Here are the two epsilon transitions that are relevant in this case. All right. So here is the NFA that I have constructed, and I can keep doing this. This is not complete. But once I've constructed this NFA, I'm interested in knowing whether a string, a stack alpha, which represents a string, read bottom to top or left to right, is it a viable prefix or not? So what am I going to do? I'm going to execute this automaton on that string. And notice that this is a non-deterministic finite automaton. So this accepts the string if any of the paths accept the string, any of the non-deterministic paths accept the string. And so let's look at some examples. So let's say my input string is t plus int star t. All right. And my question is there a path starting from the start state? So this is my start state. Is there a path starting from the start state to an accepting state such that this string is consumed? All right. And recall that all states are accepting states. So basically we are saying that does the automaton ever get stuck, or does it keep moving until the string is completely consumed? So let's see. I'm going to try to find a path that consumes t plus int star t. So, all right. So I start in the start state. Can I go in this direction? No, because this requires E. So that's not possible. But I can go on epsilon, any of the epsilon transitions. So maybe I go to E produces dot t plus E. And from there, I could take some other path, and so this is dot t plus e, and maybe I can consume t after that, right? Because my first character is a t, so I can consume t. So far I have taken this path, and then I can consume plus. So I have come here. Use a red pen to make it clearer. So right now I am in this state. And then I want to consume an int. So here I'm just consuming an e, so that's not good enough. But I can make epsilon moves, and I can make epsilon moves to any of the places. But basically I want to get to this particular state which is going to consume int star t. So I'm going to make an epsilon move to e produces t, and then I'm going to make an epsilon move to t produces int star t. And then I'm going to consume int star, and then I'm going to consume t, and I'm going to end up in this state at the end of at the end of consuming the entire input, right? So this is the state that I reach at the end of consuming the entire input. And because every state is an accepting state, this is actually a viable prefix because there is a path that reaches the accepting state in the NFA. So the answer is yes, this is a viable prefix. Okay, let's look at another example. So let's look at this example, int plus int star t. Is this a viable prefix? So once again, I'm going to start at my start state. S produces E and the dot is on the leftmost side. And I'm going to see whether I can find a path such that the entire input is consumed. So first of all, this path doesn't make sense because the first token here is an int. All right, so I'm going to make some epsilon moves. So I have two options of making an epsilon move. I could either make an epsilon move to dot t plus E, or I could make an epsilon move to dot t. E produces dot t. Now dot t doesn't make sense because there's a plus, right? So I don't think that that's going to lead me to anywhere. But if I look at dot t plus E, because this is the one that has a plus, then I'm going to come here. And now from here, I want to consume an int. Now, the option here is to consume a t, but that's not possible for us because our first token is an int. So maybe I want to make an epsilon move. If I make this epsilon move, that's not any good because the first token here is going to be an open parenthesis. So maybe I make this epsilon move, but that's not too good either because from here, I consume an int and I end up in this state called t produces int dot. But then there is no outgoing edge from this state because there's nothing, I'm not expecting anything after this. And so there's nothing here and the input is not consumed. So I'm going to get stuck on this path. So maybe I try something else. And so maybe the third thing I could try here is this one, t produces dot int star t, right? And if I do that, so if I come here, then the first token is int, that's good, but the second token is star. And that doesn't match our second token plus. And so even here, I'm going to get stuck. So in fact, for this particular string, there is no path in the NFA that's going to consume the entire string. And so this is actually not a viable prefix. Okay. Intuitively, this is not a viable prefix because it cannot be formed by concatenating the prefixes of productions, right? So in so int is a prefix of some production, but what production is it? So recall that if there's a plus, then it was p plus e, and so this int could be just a, so maybe that's a t, and then, but then I don't have anything after that to continue, right? So recall that it needs to be a stack of items such that the LHS of the n plus 1th item is the symbol following the dot in the nth item, but something like that is not possible for this particular viable prefix, and this NFA is correctly identifying that and giving you no as an answer.